All right, so today I'm going to be talking about series. It's your first time seeing series. I hope it's not your first time ever seeing series. I hope you saw it in pre-cal. If you haven't, it's okay. I can get you caught up on it, but you make sure and talk to me. Series are the first and only big topic that's different from AB. AP calls their AP says there are 4 big topics in BC and only 3 big topics in AB. The 3 big topics in AB are limits, derivatives, and integrals. That's how major this is. AB, the 4 big topics are limits, where you have a little bit of harder stuff with L'Hopital's. Derivatives, where you have very, very few things different, but you will see some stuff different. Integrals, where you have a lot of stuff different, see Unit 6. And then the 4th big idea, the one that's not in AB at all, is series. So please pay attention carefully in this lesson. Here we go. So the last lesson said that a sequence is an ordered list of numbers. In this lesson, I'm going to talk about series, which is a sum of an ordered list of numbers. So a series are sums of sequences. I'm sorry, that writing turned out so ugly. Okay, so here, this guy has a little series inside of him. Sorry, this is a series in sigma notation. That's what we call sigma notation, because that's a Greek letter sigma. It's a capital sigma. There's lowercase, whatever. This is a series in sigma notation. That's what it means. It means add up the sequence inside of it. Take the first term, take the second term, the third term, and so on and so forth until the general term. Okay? We're almost only going to be working with infinite series in this class. All right. That's the basics. Here we go. Example 1. What happens as I add more and more terms of a series? Like this. This is the series that represents adding all of the odd numbers. You should know enough number theory that you know this is an odd number. Try it. For 0 we get 1. For 1 we get 3. For 2 we get 5. Blah. Confusing. Alright, so I can make something called the sequence of partial sums. I know this is not, you don't have room for this, but it's okay. Partial sums. So the idea is, we're thinking about, well, what's sum 0? That would be just a sub 0, which would be 1. What's sum 1? That would be a sub 0 plus a sub 1, which would be 1 plus 3, which would be 4. What's sum 2? A sub 0 plus a sub 1 plus a sub 2. That would be this one plus a sub 2, which would be 9. Would be these first 3 terms, plus 2, plus a 3, which would be 16. And so on and so forth. Here we're going to get into trouble. We're getting a sum is approaching, backward spelling, approaching infinity, which we also say diverges. I'm adding $1 plus $3 plus $5. My money is growing and growing and growing without stopping. We'll call it diverges. When this happens, we call the series divergent. So on the next page now. When this happens, we call the series divergent. When I add up all the inside terms, we get infinity. We call the series divergent. This is a divergent series. Now you might think, Well, when would you ever get a convergence series? How could I add up infinitely many things and get something that converges? I would refer you back to lesson 7.1 on improper integrals, where we certainly got that. We added up an infinite amount of area, and we got a number. We got, there was 1 unit of area there. Here we go. What does this mean? Well, what's the first term of this series? The first term is 3 over 10. I don't know if you can hear the rain in this recording. That's annoying. The second term, n equals 2. The third term, n equals 3. The fourth term, just because that's what they're going to ask you to do over and over again on the test, and so on and so forth. Now, what does that mean as a decimal? That means 0.3 plus 0.03, 0.003, 3 thousandths, plus 3 10,000ths. I forgot a 0 there, sorry. 4 zeros. And you would notice you get 0.3333 ... Who is this? This is 1/3. So I call this a convergent geometric series. That's what's right below this. That would be called a convergent geometric series. So look, anyone who's a doubter, you guys, you haters, you gotta watch out for the haters. If you said, it could never ever converge, well, looky, it totally converged. I added up infinitely many things, and the idea is that the stuff I was adding was getting small quickly enough that the sum got to be close to 1 in number. Got closer and closer and closer to 1 number. So I would call this converges. I would say this converges. So geometric series are the most important type of series with which you need to be familiar with. So here's a quick presentation on them. Geometric series and geometric series test. The whole unit is going to be talking about tests. We're going to do 3 tests in this unit, and I think 3 tests in the next unit, giving us 6 tests total. That doesn't sound right. 4 tests in the next unit, 7 tests total. And when I say 7 tests total, people freak out. I'm talking about tests for convergence, tests for divergence. A geometric series is a series where consecutive terms have a common ratio r. Then the series is called a geometric series. Here's how it will look. A times r to the n. Okay? A times r to the n. So the first term with n equals 0 is just a. Then a times r to the 1. A times r to the 2. And we're adding these all together. Here's the idea. If r is greater than or equal to 1, if the absolute value of r is bigger than or equal to 1, the geometric series diverges. It's getting too big too quickly. If the absolute value of r is less than 1, the geometric series converges. And this formula. So what we're saying is it adds up. And I know where it adds up. First term over 1 minus r. So here's r, here's r, here's the first term, here's the first term. 1 is just a number. It's just part of the formula. Yes, you need to have this memorized. I cannot emphasize enough. 7.4 will try, but I cannot emphasize enough how important this is. This basically says I can turn a number into a series. 7.4, wait for it, will turn a function into a series using this formula. You must know this. And this formula only works when the absolute value of r, the multiplier, is less than 1. Not less than or equal to, strictly less than 1. R has to be a number like 1/2, negative 1/2, 1/3, negative 1/5. Okay? If R is a number like 2 or 1 or negative 1 or 5, diverges. Okay? Here we go. Determine if these series converge or diverge, and if possible, the sum of the series. I'm just going to get this stuff out of the way, because my hand's just going to move it anyway, is what I've learned. Okay. So, this is something that went by some people's heads. Okay? It might be easiest to see if I write it like this. So when n equals 0, I have 3 over 1, 3. When n equals 1, 3 over 2. When n equals 2, 3 over 4. When n equals 3, when n equals 3, 3 over 8. Okay, so what's happening? Is this geometric? I think so. It's getting closer and closer and closer. Sorry, each term is something times the last. How do I go from here to here? Multiply by 1/2. From here to here, multiply by 1/2. So this series is really this series. And a lot of people were unhappy with this. These two are equal. And you need to be able to see that. But the key thing I want to talk about, what color should I use? The first term was what? Oh, it was 3. Right there. But if you write it out like that, you see it. And the R, in orange, was 1/2. So the absolute value of R is less than 1. So I would say converges by GST. Series converges by GST. You're going to need to know whether series converge or not. That's really a huge idea. Where does it converge to? Find the sum of the series. The sum is equal to the first term over 1 minus R. That would be good enough if you don't want to simplify. But you're BC kids, so I expect you to be able to simplify that to 6. So by some happenstance, this series adds up to 6. Is that crazy? I don't know. I've been doing this so long that it seems natural to me. I added up infinitely many things, I get 6. Just the way the game works, just the way the cookie crumbles. Now this series should be staring you right in your face that this is a geometric series. Right? I don't need to rewrite it. I don't need to worry. It's times R to the n. R to the n. So this guy has R equal 3 over 2. The absolute value of R is bigger than 1. Bigger than or equal to? Sure, but definitely bigger than 1. So diverges. Diverges by GST. Done. For the record, what's A? What's the first term? Plug in the first thing. 0. A equals 1. Okay. 1's in front of there. Up! Now this one has n equals 1. This one has n equals 1. That means we're going to be very, very, very careful. Anyway, let's start writing things down. So what's the first term here? 4 times negative 1/2 to the 1. The first term is going to be negative 2. Plus 2, n equals 2. Negative 1/2 squared would be positive 1/4. 3, negative 1/2 cubed, negative 1/8. So 4 over 8 is 1/2. 4, negative 1/2 to the 4th is 1/16. So this is a very special type of series. This is called alternating. More on that later. Yeah, later. Okay. A very special series. It's alternating. But the idea is, it's definitely geometric. How do I go from one to the next? I multiply by negative 1/2. Alright, so R. Whenever you see a whole constant, that's the hardest part. I see a whole constant to the n power, a number to the n power, a number to the n power. I should be thinking geometric series. So here's R equals negative 1/2. So the absolute value of R is certainly less than or equal to 1. Oh my gosh, it's less than 1. Less than 1. So converges by GST, the geometric series test. Now, what is A? And here's how they can trick you. To a lot of people, A will be 4, but not so. If I plug in 1, what do I get? The first term was negative 2. Okay? So, the sum of this convergent geometric series is A, negative 2, over 1 minus 1 over R. Minus a minus. Wonder how many people lose points for that. And again, that's fine. But you're smart. You can simplify this. And that's where it converges to. Okay? That's a geometric series, guys. Those are the basics. Here's a little fun one. Find the fraction form of the repeating decimal 0.08 blah 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 repeating using a geometric series. Now, children, some of you may have learned a rule for this. I'm asking you to show it with the geometric series. Connell got really ornery here. It's okay. First, let's write it down. What is this? What is 0.08 repeating? Well, that means it's 0.08, followed by another 08, followed by another 08, followed by another 08, on and on and on. Sure. Could you also write this as 0.08 plus 0.0008 plus 0.000008? I'm sorry if that's getting annoying. Like that. So let's think about this in terms of fractions. Because fractions in geometric series go together like chocolate and peanut butter. I don't know. 8 over 100, 8 hundredths. Does anyone know what this is? This is 8 10,000ths. You should have a trick for this. Like, it's how many times you had to move it over plus. And that's the number of zeros. Plus 1. This is 8, 1, 2, 3, 4, 5, 6 zeros. 6 zeros is a millionaire. 1, 2, 3, 4, 5, 6, 7, 8 zeros. I don't even know. $100 million. Now you might see this as, okay, geometric series. It's definitely multiplying by something each time. Maybe you're getting into that. We can at least identify A equals 8 100ths. That's the first term. Yes? Now, how many times do I multiply this to get this? How many times do I multiply this to get this? How many more zeros does it have? 2 more, 2 more, 2 more. How do I get 2 more zeros in the denominator? Well, I multiply by 100th. For the record, that would make the series something like this. They're not asking you about this, though. Just saying this is optional. That's the series I'm looking for. The sum of it is A over 1 minus R simplify 1 minus 100th. I'll just jump to it. Is 99 100ths. Common denominator, guys. Keep change flip. The hundreds would cancel. You would get 8 over 99. Now, does that match with the formula your middle school, elementary school teacher gave you? Maybe, if you still remember that formula. The key thing is this proves the formula. Okay? If you don't know what I'm talking about with the formula, look up formula for repeating decimals. There's a nice little rule for it. You don't need to know the rule. You can do it with calculus now. Ta-da! Okay, so. A quick rule. A quick discussion. Very quick discussion. In general, the convergence of a series is less simple than the convergence of a sequence. This sequence converges because the limit of the sequence is 1. I just take the limit, and I notice that, 1 over infinity, 0 is going towards 0. 1 plus something going towards 0 is 1. So the sequence converges. However, this series, which is the sum of that sequence, I'm just writing out the terms here, plugging in 1, plugging in 2, plugging in 3, does not converge. Why doesn't this converge? Pause the video and think about it. 3, 2, 1. Okay, it does not converge because you're adding 1 plus 1 plus 1 infinitely many times. If you got paid like this, you would have infinitely many dollars. $2 plus $1.50 plus $1.33. Why is your pay going down? I don't know. But either way, you're okay. Because eventually you're just adding up $1 infinitely many times. So, these are less simple. Series are less likely to converge. However, a series cannot converge unless all the terms are approaching a limit of 0. You have to eventually be adding nothing to get convergence. This is perhaps the most misunderstood series test. Nothing converges. I'm going to write it down. Nothing converges. Oh my gosh, I can't even spell. Nothing converges by the nth term test. If you ever write or feel the urge to write, this converges by the nth term test, your reader, your grader, me, your future self will look on you with shame. Nothing can converge by the nth term test. What does this say? If the limit's not equal to 0, then the series diverges. Okay? How will people misunderstand this, misinterpret this? So if the limit equals 0, it converges? No. Nothing converges by the nth term test. If the limit equals 0, the test is inconclusive. If the limit equals 0, the test is inconclusive. You don't know whether it converges or diverges. You know it might converge. It also might diverge. It's really a question of whether this is going to 0 fast enough. And that's what all of our other tests this unit will show us, and Unit 8. It's always really a question of whether it's going to 0 fast enough. And how can we show whether it's going to 0 fast enough? But for now, to show that a series diverges, you really have one tool, the nth term test, or the geometric series test, 2 tools. It's a geometric series with r bigger than 1, or it's any other series and the limit's not going to 0. You only have a few tools in your toolbox in this unit and next unit. So, someone asks you, show that this diverges. You say, okay, it's not a geometric series. It's not a constant to the n. So let's do it. Let's try to take the limit. I don't know. Hopefully this will work out. I'm sorry. That's really annoying. N factorial, 2n factorial, plus 1. Now, as you go toward infinity, this is going toward infinity over infinity. So we'll require some technique. I'm going to show you this technique. In the future, you could just say, oh, highest power is like n factorial. Highest power is like n factorial. You might know where it's going based on me just saying that. But you ever forget, you can always do these tricks. These are always what we were talking about when we were talking about highest power. Multiply the top by 1 over n factorial. Multiply the bottom by 1 over n factorial. And what you get is something that's much more easy to understand in terms of a limit. 1 over n factorial times n factorial is 1. 2n factorial times 1 over n factorial is 2. So 1 over n factorial. This guy, as n factorial, as n goes to infinity, n factorial is getting humongous. 1 over something humongous is really close to 0. 1/2. And again, you could just say, oh, the highest power, quote unquote, matches, so it's 1/2. This is really what's going on. So since this limit equals 1/2, 1/2 is not 0. So since I have something whose limit of the inside is going to something not 0, I get diverges by the nth term test. Okay, and that's it. Again, just for good measure, going back to here, as n goes to infinity, this guy is going towards 0. It does not converge by the nth term test. That would be wrong. Nothing converges by the nth term test. This guy, n's going toward infinity, this limit's going toward infinity. You could also say this diverges by the nth term test. It also diverges by GST, and I would prefer you do it that way, but it's okay. I don't really have control over you. This one's also harder to see, but you can actually reason it out. As I multiply this fraction more and more times together, I'm getting something going towards 0. However, that doesn't help you. It does not converge by the nth term test. You have to use the geometric series test. The nth term test does not show convergence. Anyway, go try this out on 7-3's homework assignment. Remember, as always, you are not going to pass the AP test if you're not doing the homework. And, I don't know. If you are doing all the homework, if you're doing everything you're supposed to do, I'm really proud of you. I'm proud of the fact that you're spending all this time on math. Nothing can make me happier. Anyway, you guys have a nice night. You have a nice day. I know you're not doing this, but, keep up the hard work. Talk to you soon. Goodbye.